So, allow me to introduce Ray. Ray Keefe is an electronics engineer and embedded software developer with a first-class honours degree in electrical engineering and additional studies in physics, chemistry, and he also has an MBA. He's a life senior member of IEEE. Ray founded Successful Endeavours in 1997 to create electronics manufacturing opportunities in Australia because successful modern economies need advanced manufacturing as a strategic part of their commercial operations. Since then, Ray and Successful Endeavours have been winners or finalists of more than 60 awards, including Business of the Year, Product of the Year, IoT Innovation of the Year, and Manufacturer of the Year. So, ladies and gentlemen, please welcome Ray Keefe. I'll clap for you all. There we go. Welcome, Ray.
Right. Thanks for that glowing introduction, Chris. One minor amendment. I did some of an MBA and decided the answer to how to run a business properly didn't lie there, at least for me. But that is an interesting point, which is how do you learn what success looks like in whatever you're achieving? Now, before I get into the presentation, I'll kick off a couple of things that have happened since I put this together. So the strategic examination of R&D in Australia report has been landed. We contributed to the roundtables that looked at R&D in Australia and innovation in Australia, and the report has landed in the We Need a National Innovation Committee, which I think is unlikely, unless they do something different to previous ones, to lead where we need to go. Australia has had 60 commissioned reports into innovation in Australia over the last 15 years, most of which haven't led to action. And the federal government is tracking 45,000 initiatives that it has executed over the last 30 years into innovation, but without any outcomes being reported. So I think one of our challenges is we live in an environment like we're engineers. Where is the data? I want to do the calculation. I want to actually know that my solution is robust. And we've got an innovation system without the data and clearly a solution that's not currently robust. The other figure, and this is almost certainly wrong, but 4.8% of publicly funded research in Australia ends up being commercialized. That's actually the lowest rate in the world. Now, I don't know how they measure that. They claim they're using the same measurements as the rest of the OECD, but Germany's number for that is over 70%. So that 4.8% is almost certainly wrong, almost certainly too low, but representative of a big problem we've got translating ideas and research through to commercial success. So that's where this presentation comes in. So what do you have to do to have commercial success? We very much focus in the R&D playbook. We're mostly D, some are. So we're very much focused on harnessing the fruits of science, technology, and of research and turning them into practical solutions to problems that meet the criteria of an opportunity. An opportunity's got three characteristics: something you can do, something that's a need, and something that people will pay for. The intersection of that Venn diagram tends to be where opportunities lie, but you can apply a lot of innovation to how that happens. For instance, a not-for-profit has the who will pay for it as a different person to the who has the need. So it's not, it sounds really simple when I present it like that, but each one of those areas has its own nuances. All right, so let's get into this. Make sure I've got, yeah. All right, so this is me, trained as an engineer. Actually did 1 year of a science degree before deciding that I didn't know why I was doing a science degree. But that has proved really useful because having a background in analytical chemistry, biochemistry, nuclear physics has actually proven useful at times in solving problems in that space. So engineer, then I decided I wanted to help Australia by running a product development company. So I became an entrepreneur. I became a clueless entrepreneur because that's a whole skill set that nobody really teaches in Australia, as well as business is a whole skill set that it's not well taught in Australia. And so I had to learn how to build my business, which is where trying some bits of an MBA came in. I'm looking to grow the Australian economy, looking to use manufacturing. One is I've got a practical bent. Doing things you like is really useful for maintaining energy and longevity in your career. But the other side of it is that the World Bank and the International Monetary Fund have determined that manufacturing is the best way to lift populations out of poverty. And so that's why they're using it in Asia to try and lift that whole continent out of poverty. China has really cottoned onto this, but they used Japan as the model. So Japan showed how they lift their economy out of World War II era and how they transitioned from their products being referred to as Jap crap to products which are actually seen as being, really great technology. Um, and they were the ones who got the quality thing by Deming, which is quality management is a process. And if you apply it to your systems and make your systems better, your outcomes get better. Deming's quote is 94% of the problem is the system. So most of our issues are not people. Most of our issues are the systems that these people are trying to function within. Um, so, founded Successful Endeavours 28 years ago as a way of trying to achieve this. I've got grandchildren. I think we should leave them a functional economy. That's the first step. And I also believe that we're making a mess of the world at the moment, which is not news. Humanity's always made a mess of the world. It's the details vary with generation, but solving some of today's problems, such as environmental pollution, such as the climate challenge, such as the energy challenge. We're seeing that at the moment with oil, petrol prices, all that sort of stuff. These are all hot topics. The solutions to these problems are going to require better thinking than the thinking that got us into the mess. But it's also going to require capability and capacity. There's no point having sovereign capability if you've got no capacity. Sovereign capability, which is one building in the middle of nowhere that can do it, is actually not an industry. All right. So a little bit of a look at that. We design other people's products for them. So we're R&D for hire. We focus on electronics and smart products. I was the pub guitarist who thought it would be cool to design my own amp and rack and rig. That's what got me into electronics. That was one of the things I tried in my gap year in between first year science and first year engineering. And so I found something that I love. I found something that was interesting. I found something that was intellectually challenging. And electronics has got a lot more maths in it than most of the other disciplines to actually leverage as part of the solution space. So it turned out to be an excellent fit for me. Since over those 28 years, we've done 3,000 projects. We're actually, I just clicked over 4,000 invoices, but invoices and projects don't map one to one. 90% of those products ended up being made in Australia. So we have that made in Australia focus from day one. If you're going to solve a problem, you need to frame it properly at the beginning. And if you're going to make a product in Australia, there are some challenges. So you've got to look at that from the beginning. So I'm going to be sharing how we managed to do that. And we're going to be using the products that on screen here are some examples. So why manufacturing? First of all, it creates fundamental value. Secondly, it creates a lot of jobs. And then it creates even more jobs in the businesses around it. According to most industry statistics, one job directly in a manufacturer creates between 2.5 and 7 jobs around it, depending on the nature of the manufacturer and the nature of the industry. But if you look at the Australian landscape, we currently have 870,000 direct jobs in manufacturing. 84% of them are full-time. There are 9.4 million full-time jobs in the whole economy. 27% of the current jobs in the Australian economy, full-time jobs, are actually dependent on Australian manufacturing for their existence. So I really think we should be looking after it better than we are. That's just the engineering maths brain kicking in at this point. The other thing that it does is it spreads wealth evenly through a community more effectively than any other industry because it creates jobs at every level. And so it's not, if you look at a lawyer or an accountant, they don't create much around them in terms of other jobs. Manufacturing really does. The other one that does this is trades and construction, which is one of the reasons why Victoria is using it so much. Um, it gives us resources and capability for the future that, you know, my grandchildren might have a hope of fixing things. It prevents us being commercially hostage. If you buy everything you need from overseas and the ships stop coming, what happens? I mean, that's a real thing to be thinking about right at the moment. Uh, but it also keeps a lot of the economic benefit, the value creation, and the money that's being made, because you have to make money from things one way or another for them to be remain viable, um, actually remains in Australia. At the moment, if you take the gas industry, we're shipping both the product and the profits offshore. So it's got almost no benefit to Australia apart from balance of trade. And because we're not getting paid enough for it, it doesn't even help that enough. All right, so how's it been going? I got a business coach because I discovered that I didn't know how to run a business. Because at engineering school, they got way too much engineering to teach you to actually cover some of this other stuff. Um, and it took me a while to find one because I needed someone who could help me with what I was trying to do. Um, the business coaching industry has a lot of people who can't run their own small business consultancies properly, but trying to convince you they'll magically do better with you. So finding someone who is both the right fit, the right skill set, and broad enough, because many of these people are great in their area of expertise, but a business has to function across the board in order to grow and be successful. So it took me a while. I got two questions early in this process. The first one was, are you any good? Which he followed up with, I don't believe you. You have to prove it. And he said, I can pay people to make you look good. I can make your website, I can make your brochure look great. But if there's no substance behind that, it all falls over. So how are you going to prove it? So we went down the path of awards. The ones at the bottom left corner, pair of National Innovation Awards, were the ones that kicked it off. And what really cemented this for me, and this is something to think about with, this is a sales process. How are you going to convince somebody you're trying to sell an idea to, sell a change to, sell a product? It doesn't matter what it is, that it's a good idea for them to say yes. How do you get them to the point where they're nodding with you? Well, they need some proof that this journey is not going to be a disaster, that this journey is going to work for them. So having been notified that we were finalists for this award, I let a number of our clients and prospects know. And one of our new clients came back to us and thanked me for doing it. And in his words, um, they were they were taking a big risk with us as they saw it. And just being a finalist had already made them comfortable that they'd made a good choice. So this isn't about misrepresenting things. This is about helping people to have confidence. All right. Um, what we do is somebody else has got an idea, but how you turn a great idea into a great product. Um, so that's where we come in. So we do that translation from the idea through to what you've actually got in terms of a circuit board or software running or support systems around it. Um, so this gets you a new electronics product that works correctly and reliably. 30% of our projects, somebody else had to go out and screwed up in some way. The details vary, but in one case, we were the fifth business a client came to because it involved analog design and it involved an understanding of things like transfer functions of op amps and gain bandwidth and things that people didn't even realize were factors. Um, Secondly, is it compliant with standards? So we have this thing called the RCM, which is the mark on the right hand side of the screen. To put that on a product, you are meant to be holding proof that it's compliant, which means you need to get it tested by a certified test lab. So if you want a product to pass that, it has to meet some criteria. We want to be able to make it in Australia and make a profit. We want to grow the business. So if we want businesses whose success exceeds their aspirations so that they've really got to get on their bike and grow it. We want to support the Australian economy, but most importantly, it leaves you in complete control of your destiny in terms of IP, in terms of manufacturing capability, in terms of being able to go and knock on a door and speak English to someone about an issue that you're having. Uh, right. So there are some challenges here. The first one is my biggest competitor is not that you can go off to one of the other consultancies in Australia who offer the same services that we offer. My biggest competitor is the idea already present in people's heads that you just can't do this in Australia anymore, that we don't make anything. In fact, when I share that 870,000 direct jobs in Australian manufacturing, most people are going, what? Nah, it all left with the car industry.
Mm.
You get that sort of reaction. So we've got to speak some truth. I've discovered that having a bunch of statistics at hand in my head really helps with giving people confidence that they can look at this problem differently. So this is actually a problem to be solved. And so I've got to have some tools to help people with it. So this myth is just completely untrue. And so there's a number of figures. Even though manufacturing in Australia is bigger than it was in 2016, it has not grown in line with GDP to the same degree. So it's shrunk slightly as a percentage of GDP, and Australia currently has the lowest percentage of manufacturing to GDP of any country in the OECD. Germany's manufacturing exports exceed our GDP, and we're the 13th largest economy in the world. So Australia, high business costs. People say can't afford labor. No, you can't afford anything. It's not just labor. I mean, it's tax, it's compliance, it's insurance. Ask someone in Asia what their work cover costs are. The answer is what's work cover? So we have a lot of structural costs. Getting a container delivered to West Swanson Terminal costs less than getting it on a truck and delivered to your premises in Melbourne. So we've got a lot of structural things here to take into account. So we've got to look at how we navigate that minefield so that we don't incur unnecessary costs. We have the lowest rate of business-to-business collaboration in the world. So we are ranked as country number 186 out of 186 for business-to-business collaboration. We also have the lowest rate of university to industry engagement in the world. So country 186 out of 186 for that. And the lowest rate of publicly funded research commercialization in the world at 4.8%. So that 4.8%, as I said before, is almost certainly too low, but it represents a big problem. We have low economic complexity. So we're ranked at 105th in the world for economic complexity, 106th in the world for commercialization capability, bottom 8th of the world for access to finance, and the average Australian manager ranks at 30% of OECD average for management competence. Now, these numbers are gleaned from publicly available data and projects which have public disclosure requirements because they're public-private partnerships or they have funding associated with them that requires disclosure. And they're also a little unfair. If you're doing a logistics project in the Pilbara, you have a much bigger problem than if you're doing a logistics project in the middle of Germany. So our geography contributes to that score. Nevertheless, it says that there are some opportunities for improvement here. From my perspective, these potential pain points are actually opportunity. If you address these in what you're trying to do, then you're actually going to be well ahead of average. So this is our number one theory we've come to for product development, which is you have to make all the stakeholders happy. You don't have to make them all equally happy. That's actually impossible, but they all have to be happy enough. But there's a lot of people here. Now, the part of this process we're normally involved in allows us to narrow that down a bit. But when we're doing product requirements, we'll be asking people, well, What does the installation person need? What does the commissioning person need? Well, what is the person taking calls from the customer about when the product's not behaving itself? What do they need? What does the user need? What is, if it goes back for service or repair, what does that need? Because when we're designing a product from the beginning, we should be designing around the needs of all of that. What does the manufacturer need? Do you even know who that's going to be? Do you know what their capabilities are? My number one rule in design for manufacture is design for a manufacturer's capability. Actually draw an envelope and say, we can only support manufacturers who have capabilities that fall within this boundary. So we don't take a product to someone who can't actually make it. So it gets a bit simpler. We're generally involved in this part of the equation in terms of where most of our activity happens. We have to understand the rest of it, but from what is the business case to the product development process to the market ready product, that tends to be the journey that we're on. And you'll notice that there are two big inputs here. So product development process has lots of inputs. As I said, we care about all the stakeholders. So we need inputs from everyone. And the other one that gets overlooked a lot in Australia is funding, which is how you're going to fund it. Everyone says, I need a government grant. Not going to happen. There's already plenty of organisations set up to consume the government grants while delivering no outcomes. We've just had a productivity roundtable. That one should have been front and center, quite frankly. It at least did work out that management performance is a productivity problem in Australia. But, invested money not actually turning into actual solutions is a big problem in Australia. So this is our number one rule for success, is every stakeholder has to be happy enough. So working out how to tick their boxes is one of the key drivers to a business case success. So we might look like an engineering company designing circuit boards, but we're actually solving for another problem. The problem with this one is it's not solved for X, it's solved for the whole alphabet equally well for every letter. Or the other one is you've got to work out what the primary driver of the project is. So project management theory says cost, time, performance, sometimes cost, time, quality. Pick two. I've worked out that you actually got to pick one. So our process says pick one. And so we're going to show some case studies which look at what pick one did for a particular project. So is it the time that matters most? Usually this is time to market. What's the opportunity window? If you're doing a project which does have funding support that has a hard deadline for delivery, you have a time problem to be solved. And in some of those cases, you should forget about cost and performance and work out how you're going to solve the time problem first. So this is one which had cost pressure. So believe it or not, that's a 6 water meter, pulse water meter module. And this particular project won Environmental Solution of the Year 2020. The problem is that if you're going to retrofit solutions to existing buildings, you've got to live with what's already been installed most of the time, which is generally water meters like this, or if not, water meters like this that you can put a pulse probe in. There is a big trend towards NB-IoT connected water meters, and we also work in that space. But there are issues with cellular connectivity costs and platform costs and other things in that space. So the problem here is retrofitting. The project that kicked this off, the buildings had all been built. Some of the tenants have already moved in, and the project managers are telling the plumbers that they're responsible for fitting the AMR solution, which nobody else is allowed for. The people who did the building automation systems haven't run any wires for it. The cost of running a wire is more expensive than the water meter. And so it's a total cost of ownership problem with installation cost, communications cost, and the product cost having to fit inside an envelope. And it's a B2B commercial niche, because this is a business selling to plumbers who are selling to uh, the building project owners. Actually, yeah. All right. So how did we do this? So the circuit board's on the left. That's what's on the circuit board. If you're going to make a low cost product in Australia, have nothing on the circuit board is a really good strategy. So do as much as you can in software. So the uBlocks module at the right-hand side of there um, is the only item in this product that has any cost associated with it. Everything else on here is pretty trivial. The super cap for battery hold-up. So this is running off a primary cell battery, 10-year battery life. So in-field 10-year battery life. Nobody's getting charging near this thing. And it uses a wireless mesh networking protocol from a company called Wirepass. So these things are operating at 2.4 gig. The mesh builds throughout the whole shopping This is a whole shopping precinct. This is not one building. This is a whole shopping precinct called Docklands and Harbour Town and all that area. And there are two gateways, one at each end. So the nodes actually act as the transport mechanism. They replace the wires, and there's only two SIM cards involved. So there's $5,000 a year of cost taken out of the OPEX budget because of the lack of SIM cards. But they don't have any OPEX budget, so our client quite sensibly sold them 10 years worth of communications cost as part of the CapEx. So this is another thing, CapEx versus OPEX. You can often make a deal work if you put the money in the right bucket. Put the money in the bucket that's actually able to hold the expense. So there's a lot of structuring of the deal stuff that goes on here. And so the total cost of ownership here meant that the plumbers could afford to actually deliver a solution. And the business that we were dealing with here, our client, which is Water Synergy Group, were able to then effectively fund a new product category for their business based on the first project. Now, this is another tip for startups. Get a lead customer who has a big enough problem that they'll actually help fund the journey towards a solution. This is the number one way startups succeed in Europe. The number one way they try and succeed in America is find some sucker to pay all the bills and throw money at the wall and spend other people's money until you find something that works. That does not work in Australia. So find a lead customer is my advice for startups. Find someone who, it's the doctor's thing. Where does it hurt? Where does it hurt enough that you'll pay to get the problem fixed? This is one of our quirky projects, digital bagpipe. So bagpipes have a problem. They're loud, they're big, they're awkward. And if you are a learner, then your family wants you to move out if you practice a lot. So our client is an internationally recognized bagpipe player, Murray Blair. I've put a link on this one for anyone who's interested to go and have a look. So this is a commercially on the market product. This is a consumer niche product. But that said, this is the leading product in the world in its category, and the two main markets are Scotland and the US. So this is a designed in Melbourne, made in Melbourne, and most of them ship somewhere else. So the Murray also teaches bagpipe and he runs a business on the side selling accessories for bagpipes. And he's very frustrated that his students are not allowed to practice enough. And there are these things called practice chanters you can get, but they're still really loud. And then there are some new digital products coming on the market, but they're terrible in terms of feeling like you're playing a bagpipe. So players need to practice and their families need peace. This is the problem. This is the problem that we're trying to work out. So when we started this project, the brief was, how cheap could we make a practice chanter? Once we answered that question and given him something that at least worked to a degree, and he understood what was possible, he pivoted the brief to how good could we have a practice chanter. So this moved it from a cost pressure to a performance priority. And so he's now the world leader in this space. And it's a case of, so this is basically a Fairlight CMI inside a bagpipe chanter, but only one sound channel. So there are three drones and there's the chanter itself. The samples we are using are actually recorded from bagpipes and sliced using the same looping technology that synthesizers use to do sound playback. Murray's an expert at this because he does this stuff with his digital audio workstation. Uh, and so we're basically building the playback version of that into this with an STM32 micro. And the extra flash that we don't need, we've got a megabyte of flash here. The extra flash we don't need for the actual processing engine and GUI is actually used to store the samples. So it's a very, very compact solution, internal rechargeable battery, and we're about to start on a version 2 of that. So Murray won't mind me saying that because everybody's asking for it. So really nice, quirky project. This one is a product that listens electrostatically to the overhead wires in the distribution grid. So this is 3 kV up to 66 kV in Australia. Can do other higher voltages, but generally it's not used there because they have less faults, because generally the insulators are built better. So the problems that they have are insulators going through partial discharge. So that means the insulator is eating itself from the inside out by internal plasma distribution due to the electric field across it. And when it finally breaks through to the skin of the insulator, you generally will have a bang, a lot of shrapnel, and potentially a bushfire, depending on where this actually happens. But you'll also have an unplanned outage. Um, and it also pick up things like if you've got a wire snapped in a large bundle, then you get this thing called corona discharge at the ends. So if you're at 11,000 volts AC, then the ends of this cable will actually slowly evaporate away until eventually it gets down to the wire, and then it'll keep going through the wire until it actually gets through the wire as well. This was what caused the Marysville fire on Black Saturday. And so it's a common fault source. This is one of the faults that this technology finds really well. It samples at 250 megasamples per second with an FPGA and real-time maths processing so that you can get in the order of a few meters resolution. Different stations are time synchronized to the atomic clocks in the GPS satellites to actually get time-aligned accuracy of sampling in the network. And then it reports back every second the most interesting thing it saw and when within that second, and then some back-end software looks for signature matches and then runs the electrical energy through cables, goes at about 90% of the speed of light modeling back through a diagram of the network and says it's happening here. So this is the leading product in the world in this space. It's probably, there are some who are doing for underground cables using TDR techniques, but this is the only product doing it like this. California can't buy them fast enough because over there you get sued if you start a bushfire. In Victoria, it would appear you get psychological counselling and some kind of a bonus to help your mental health if you're a power company who starts a bushfire. So I think we need to look at the licenses we've given people to operate and make sure that they actually operate according to them. Um, because there's no driver in Victoria, there's no impetus to really install these significantly, even though the early trials were all done and were very successful in Victoria. Whereas overseas, where there are commercial imperatives because there are penalties, that actually drives take up of the solution. Now, here's the problem they had. PhD project showed that an IEEE white paper from 2002 ideas was sound and that it could be done. The professor one of the professors there said we should spin this out into a startup. The university IP lawyers went, and eventually he went and did it on his own. So he then went and talked to the utilities and he sold a trial for 6 units. He then went looking for someone to develop it. And so we were engaged to produce the first version of this solution 16 weeks out from the you must install it by now date. So we have a time problem. Because we've got a time problem, we're developing as little new technology as possible, which means I'm buying an off-the-shelf computer for the FPGA. I'm buying an EVK for the FPGA that has a connector on it that I can plug an EVK for the 250 megasample per second ADC into, so that they actually come as a match set. And I've got 90% of my technology in two EVKs at this point. And then we custom design power management, communications, weather station interfaces. One of the things they're looking at here is you get different type of level of sort of readings when it's wet and when it's dry. So they actually use that as part of the qualifying what a nasty signal is. Also, insulators that are dirty will occasionally arc track when the pollution on them is moist, which generally removes the problem at that point and it goes away. So they're a different class of fault to the insulator itself is failing. So the way that we did this was we designed the minimal amount of electronics we could, built them, tested them, and made sure they were solid. We put it in a box. It didn't look pretty. So pretty comes later in this particular case. And we made sure that the basic FPGA system is running, that we've got the Linux drivers running. We're running Python scripts in Linux. We've got the communications to the web. We can SSH into the box securely, and we can upgrade the Python scripts to upgrade what's happening. We can upgrade the FPGA image. And so those shipped so that they could be installed on time, but they didn't fully work yet. And we plan to address the not fully work yet as part of the commissioning process. So the installation date was the 23rd of December, which got us another month because although we delivered the hardware on time, they didn't actually install them until after the 26th of January. So, but the funding had a requirement that they be in store. And in fact, one of the field trials for this technology was the funding had a requirement that they be in store. So solve the actual problem. The biggest problem here is in store. The second biggest problem then is make it work, given that there's a PhD project that we don't yet have access to the IP for that actually supposedly made it work. And it's hard as a problem. As a technical problem, this one's tricky. So this was successful. I&D Technology are now making these things in batches of 4,000 units. And, so that's an example of a box on a pole, solar powered. The other problem we had with the second trial, which was a state government funded trial in the SWIR distribution network, is that the product was, again, had a fixed delivery date. If it's not delivered on the date, the grant funding goes away. I mean, this is not a good scheme if you're trying to get innovation happening, but that's a separate conversation. So we were told they were putting them on poles with VTs, voltage transformers, so they'd be able to pole them from the LV side of that. The people who had the VTs on the poles with the existing monitoring equipment and sectionalizers and reclosers and all that sort of stuff said, we do not guarantee system behavior if you can't connect to anything else to this that we don't have control of. And so suddenly they had to become solar powered. So this was, again, a 16-week project, and that revelation was 8 weeks into the 16-week project. So that was a big pivot in the middle of it. We pulled this off, not just because we're innovative, but we put a whole, unlike the first time, which we did all ourselves and you got the mechanical mess from it that we were capable of generating. The second time we're designing it so it looks right. We're designing it so that it's buildable and scalable. We're delivering 65 systems, not 6. And we still have a tight time budget, but we'd lined up somebody else to do the PCBs. We'd lined up somebody else to do the mechanical design. We'd lined up somebody else to do the bracket fabrication. We'd lined somebody else to do the cabling. So I actually have a blog post on our blog called 2020 Year of Collaboration, which actually maps the ecosystem as collaborative suppliers we built to be able to do this. And so that project was delivered on time because we had not just us, but we had built the right team of other businesses. And this is something else to think of with innovation is innovation isn't just what happens in your building. Innovation is what happens in your ecosystem. And if it's a big job, you need help. So you're going to have partners. So the question is not, will you partner? The question is, how will you decide who you partner with? What does that criteria look like? So this particular one is a B2B industrial product. And here's the basic formula. So that's what the third generation of it looks like. This is the tidy version. I'm not going to put a picture up of the first generation. The second generation was tidy but not compact. This is tidy and compact. So focus on minimum viable product. So if I read Elon Musk's biography, it'll obviously be part one only over the summer. And he's got this absolutely ruthless process for look at a requirement. Who wrote it? Why did they write it? If you don't know what they write it, can we go talk to them? If the answer to that is no, then delete it. So, and he's doing this with NASA's launch systems in SpaceX. He's saying, can we talk to the person who wrote the requirement? No, okay, delete it. I said, you can't do that. He said, it's our contract. We can do it. So, really ruthless approach to challenging requirements. I thoroughly believe requirements should be challenged. I'm not that ruthless because generally they're written for a reason. I'm trying to understand the reason. His other one on system complexity is if a product costs a certain amount and you look at what the cost of the raw materials is and you allow some factoring for processing costs, if the selling price is more than 10 times that number, then you're an idiot to buy it. We'll make it ourselves. And he's applying this to, okay, a injection pump, oxygen injection pump for a rocket system is $3 million. They do the maths and they go, well, there's about 30 grand worth of parts in here. So we'll do it ourselves. Now the first one blows up, of course, because that's the nature of these things, but he's very tolerant of that risk. In fact, he relies on that risk. His other one is look at the parts in something, and if you're not sure why a part is there and no one knows the answer, delete it. And if we don't have to put at least 10% of them back, we didn't take enough out. So it really drives the system engineering process in a way that I would be extremely uncomfortable with. But it's getting results. It's really hard on the employees. So from his biography, you can pick up he really cares about the human race. Individual people is the struggle. So he'd be a very difficult person to work for. But his methods have actually made some big breakthroughs. So minimum viable product, pull complexity out, get the hardware working early, build as soon as possible so you can test. You want to know the hardware platform is working because you're going to install it. So fully test it before then. Software development continues past the installation date. We're in generation 4. The one you've got on the screen there is generation 3. And this is a 98% export product with no competitors in the world. And one of the good moments. So it won quite a few awards. This was the first of them, which was the Pace Zenith Best Networking Implementation Award. This one was a bit of a surprise, but Alan, who founded I&D Technology, is the guy on the right-hand side of the left-hand picture. All right, so our proven process is you need a good enough product idea. Only has to be good enough. Harvard Business School says that a B grade management team with an A grade idea will always be beaten by an A grade management team with a B grade idea. Um, you need consistent stakeholders. You need to consider the stakeholders. So do the stakeholder map, determine what the pressure point is, and see if there's a business case. You don't start product development until then. There's no point wasting money on the product development process if the business case says the product has to be different. That just generates a lot of rework and churn. Our focus on Australian manufacture from day one. So you've got a great product that is made in Australia. Not only can it be done, but it's regularly done. So if you want to try us out, this is how you do it. So take the QR code or the contact form, or um, ask the organisers of this to put you in contact with me. There's lots of different ways. And thank you.
Thank you.
Great. That's terrific, Ray. Thanks very much. Some very interesting points there. And it's been a pleasure listening to you. Now, let's go to questions. Have we got any questions in the chat? I don't think we have, other than turn your mute off or mute your microphone. It's a bit late for that. Does anyone want to put up their hand and ask a question, perhaps? Look, that isn't surprising, Ray, because you did cover the ground so well. I loved your story about Elon Musk. I've read his books. Interesting character.
Oh, definitely.
And yeah, by the way, have you read Maverick? That's another good manufacturing story.
No, I haven't read that one. The Great Game of Business is an interesting one, and on how you make on the value of making the business's financial performance visible to the employees to
Yeah,
give them a stake in the game,
yeah,
and then tying a percentage of their remuneration to
yep,
achieving above targets and that sort of stuff. The one that got me was the Netflix story, No Rules Rules, it's called.
yeah,
And they went through a hard time where they were trying to do a deal with Blockbuster. It didn't work. The market tanked a bit during the GFC, and they had to let it go of a third of their staff. So they had to work out, all right, who do we get rid of? How do we decide? And so they came up with this formula, which is they wanted to keep their talented people. So anyone who was exceptionally talented, they wanted to hang on to. Um, they wanted to keep their people who were really great contributors and worked well with other people, and really got on board with ideas, weren't difficult to deal with, weren't toxic from one perspective. And then they wanted to keep people who they didn't have to clean up the mess after too often. So consistently good judgment. So they had this concept of talent density, so lots of talent. They had then able to work with others, plays nicely with others. So highly talented, plays nicely with others, and consistently good judgment. So on that basis, they actually got rid of slightly more of their workforce.
Sounds a
Then
little bit like the challenge that Mike Cannon Brooks has had at recently in getting rid of some of his staff and a few others
yes,
involving AI. Look,
yeah. Anyway, making this move doubled their turnover.
yeah, oh,
Two-thirds of the
amazing.
staff double the turnover, and that's because there are things that hold you back,
Mm,
and they aren't just stingy customers.
no, that's right.
So you've got your own internal stuff. Yeah.
Yeah. One of the things dear to my heart is manufacturing in Bendigo. About half of our economy depends on manufacturing and mining. Um, uh, One of the things that have noticed is there is almost like a glass ceiling in that you can get to a certain level in manufacturing, but getting to go that extra level, see that extra vision and that bigger picture is a bit hard. And some of these businesses are terrific, and you can't always just blame bureaucracy. So have you come across this where you've got a manufacturing business, it's ticking along nicely, but there are opportunities to do better? And is it simply that the owners of the business, why work harder or smarter when you've already got a profitable business?
Yeah. So if we look at this through the lens of how you do it in Europe, they have a lot more family businesses and businesses that grow up through the mid-size enterprise. scale. The US does it on, I think, sheer concept of leverage. So if you're in the US, you're looking for who you can exploit, basically. Capitalism at its heart is built on the idea that I can get paid more for taking what you've done and adding something around it than I have to pay you. And so, profit margin in the middle. The key characteristics of Australia is that 96.4% of all Australian businesses are less than $1 million in turnover and less than 5 employees. So
Mm.
we are overwhelmingly small businesses. The large businesses side of the equation are responsible for only a few percent of the employment, but 24% of the GDP.
Yeah.
So there's a lot of money happens there. And the middle-sized enterprise, the bit in between small and large, there's only 14,000 businesses in Australia in that space.
Yeah, right.
So our last in the world for business to business collaboration and low management competence is one of the things that's keeping those small businesses small. So the single biggest lever we have in the economy is upskilling the mindsets and the business skills of the people running those small enterprises so that they can scale. Businesses go through cycles. So there's Goldratt wrote a book called The Goal, which looks at the theory of constraints as applies to business operations. But it's assuming a business has already got size and capacity.
Yeah.
Getting to that point is the journey. That's the one I wanted to understand when I started my MBA and decided that MBA is like, I want to understand a skeleton. So let's pick up one bone in isolation, talk about it on its own, put it back down. And then at the end of that process, when you've worked your way around all the bones, you now say, I know everything about how to make a person. Well, no, you've got a lot of useful domain expertise, but in isolation. Nobody really teaches how to put this together. So I
Yeah.
think one of our weaknesses in Australia is the low collaboration, high resourcefulness. So there's a plus counter side to this low collaboration coin. But the problem with the high resourcefulness is you're almost saying to yourself, I should get some help here, but I've got some barbed wire over there. I'm going to try it myself first. And
Yeah.
because we're resourceful, you get away with it enough.
Mm.
So the book I would read if you wanted to understand this is 10x is easier than 2x because
Mm.
10x requires you to change the structure of the business.
Yeah, right.
2x, you can delude yourself that you can just add 5% to the sales funnel, 5% to the efficiency funnel, 5% to the order funnel, bigger mix of products. You can get to two, you can have a number of ways of slicing this pie to get to 2x, but 10x requires you to rethink the business. The reason that businesses get stuck at a certain size is because their structure doesn't support the next layer of growth. I've got exactly this problem. We've got a
Yeah.
2030 vision that my current business structure can't achieve. So
Yeah.
I'm actually going through the process of what does the structure look like. I've got a small team of highly multi-talented people, what you'd call polymaths,
Yeah.
but mavericks aren't the right answer to certain types of problems. And certainly, if you want to tackle larger problems, you need teams with specialists and with boundaries and things like that. So we've gotten away, if you like those small business owners with their barbed wire. We've got away with doing it a certain way up until now, but that way doesn't take us forward. So the business has to restructure. The business has to have more intentionality. We've got away with not being ISO 9001 compliant up until now, but we're going through that certification process at the moment, not for a tick box so that more people will feel
Mm.
comfortable buying from us, but to codify how we've been able to be successful up until now.
Yeah, Ray, I just want to sneak in another question because time's running out. You mentioned earlier about um, our sovereign capacity or capability. Right now, of course, with the war in the Middle East, that's being really highlighted. We're running out of resources and so on. Um, but I like your comment about these problems can be an opportunity because I read today, for example, where BHP is about to have a strike with its workers. They're demanding that their pay be doubled. Now, for me, that would be an indicator that BHP is going to be looking for all sorts of innovation because the workforce doubling the cost is just going to be horrendous for them. What do you say about that?
Okay, there's more than one angle to this problem. You're
And
quite
you've only
right.
got 4 minutes or
Yeah,
three because I need to
yeah,
thank you.
yeah. A large structural cost problem like that is real. So BHP have got to look at cost structure value equation. Um, Real wages in Australia have been not growing at the same rate as CPI now for 30 years. In the US, it's 50 years. And so we do have a legitimate whinge by the value creators. And all of this is being done in isolation. So industry policy means that the government provides direction for their preferred areas for economic investment and economic outcomes in Australia. We haven't had one of them for 30 years either. We've had tick box politics. So what I would say is that it's going to be very difficult for anyone to win this fight, whatever win actually looks like, uh, because the workers have a legitimate beef. Their AMBIT claim of 2x is somewhere that BHP probably can't go. BHP have a legitimate whinge because they have business operations depending on some stability in cost structure. And the whole of Australia should have a whinge that the government's actually not providing a vision of where we're going. What is Australia's 2030 plan,
Mm, mm,
2040 plan, 2050 plan? So that's what I would say about that. You're right, BHP are going to have to innovate, but it's about time we started looking at workforce innovation as well.
mm. Excellent. Well, Ray, that's been a fascinating discussion today. Thanks so much for your time. And thanks also to everybody who's joined this seminar. As I said earlier, you can email your comments to our secretary, and this webinar will be posted on our
Yep.
website and on
And you have my
YouTube.
slide deck, so you're welcome
Yep.
to give that to anybody you think will find it useful.
Terrific. So thanks again, Ray, for your time today and the work you've put into this seminar. And if everybody knows how to give a clap online, consider it done. Thanks, Ray. Thanks again for your time. Look at that. Look at that. Look at all those claps. Wonderful. Good on you, Ray. Thanks very
Okay.
much.
Thank you,
Thanks,
everybody.
everyone.
Have a great day.
Bye.
Thank you.